I live in Puerto Rico. A little bit about me. I've been doing accessibility for a little bit over 14 years now. I founded the Axe Core open source accessibility software library that has been downloaded about 1 billion times from npm.js. And I wrote a book on Agile accessible software development called The Agile Accessibility Handbook. Deque is a mission-driven company. Our mission is digital equality. And the way we like to do that is to focus on tools. And so those tools that we focus on are tools that deal with all aspects of the software development lifecycle, all the way from designers through the development team, all the way through monitoring your production systems. So what I'm showing you here is a stylized diagram of the Agile software development process. You can see on the left, there's a designer who has design comps and is working with product owners and product managers to create tickets. Those get picked up by a front-end developer who codes them. They are generally using tools like linters and other automated testing tools like Cypress in their product to make sure that the code quality that they're producing is good. They may or may not write the automated tests themselves. There might be some test automation engineers writing tests with them. The code changes go into a branch and a pull request gets open, that gets reviewed. And if it passes all the code quality stuff, including things like security checks, etc., it gets merged and makes its way out into production. With the Axe suite of automation, of which some of the stuff that Brian talked about that's upcoming here for Cypress is one example. Using the Axe Core library, you can achieve quite a lot of accessibility without having to really know much at all. So using a tool like Axe for Designers, you can test your designs within Figma, and then you can annotate those designs and pass that on to the developers. Within VS Code extension, for example, you can use the Axe linter to find and fix your accessibility issues there. One of the great features about that tool is that it knows, you can teach it about your own component library or your design system, so that if you've built accessibility into that component system or design system, that accessibility can be a guarantee to carry through the use of that. So you can actually lint for the use of your design system as well as while you're developing your design system itself. Then, of course, the Axe tests integrated into your Cypress end-to-end testing suite. And if all of that information is checked within the pull request, it can achieve find 57% of the issues which you can fix before your pull request gets merged. Now, one thing about how we measure coverage here is we measure it by risk and by effort. And so that 57% is based on data that we have, where we have taken all the accessibility assessments we've done for our customers before they start fixing their code. And we've looked at how many of those were found by our automation versus how many of them were found with manual testing. And this is how we come up with that number. So obviously, tools like Axe can find a lot of these things for you, but they aren't going to get you 100% of the way there. There's still quite a lot of a gap. So if you're using a tool like, for example, Lighthouse from Google, any tool based on Axe or a similar type of thing, it's not going to make your application completely accessible, even though it's adding a lot of value and finding a lot of things. So the question is, well, how do you do the rest of it? And in particular, how do you get to 100% if you're trying to do it in an agile environment? Because one of the myths that's out there is that software development cannot be done, accessible software development cannot be done in an agile way. Well, the way that you do it, if you're just using assistive technologies, is you train all your developers and QA people to become accessibility experts. There's a lot of organizations that do this sort of training. We have online training at Deque University. They would then use that assistive technology during development to test what they're actually developing. In the same way that if you're developing some UI, you might use a mouse and a keyboard to interact with that. You would do the same thing with your assistive technology. You would fix any of the issues that are found, and then you write end-to-end or unit tests to make sure that those things don't regress as you make changes to your application, and you rinse and repeat over and over again. The biggest problem with this is it takes about a year of intense work for somebody to go from being kind of a casual accessibility front-end developer to being someone who really is well voiced in this sort of thing and can do it kind of in their sleep, where it's not adding a huge amount of effort, and where the results that are being produced are not inconsistent or incorrect in some cases, right? So it's very difficult for organizations to move up that learning curve and get to the point where they can do it in this way. But if you're doing it this way, then using Cypress, for example, this is one way you could write a unit test to test for accessibility. In this case, what I'm showing is some code where there's a logo on the page, and we're using Cypress to get that logo. In this case, image with source equal logo.png, making sure that it exists. Now, if somebody goes and changes the page and removes the logo, or changes the logo URL to point to a different image, obviously this test is going to break, and then you're going to have to go back in and ensure that whatever change was made is still accessible. But from an accessibility point of view, the next assertion is really the important one, to make sure that the alt attribute, which would then allow that image to be read out to somebody using a screen reader, a blind person, for example, that has a particular value that matches that image itself. In this case, the alt attribute you're looking for is Deque logo. And this is the way that you would build, and similar way that you would build these sorts of regression tests into your testing suite. So the alternative to really having to do all that learning and become an expert is a suite, a category of tools that we invented. We are not the only tools that are out there, but we're definitely, in our opinion, the best. That does what is called intelligent guided testing. And this is a set of semi-automated tools. And with our tool, for example, you can find up to 84% of the most common accessibility problems without having to pick up any of that accessibility specialist knowledge. The way it works is you start a particular test. So, for example, we have a test, IGT, to do table testing, to do keyboard testing, to do modal dialogue testing, interactive elements, testing the whole structure of the page, testing images, and testing forms. And the way that we've chosen these particular intelligent guided tests is we focused on the areas where there are a lot of mistakes that are made because they're very common or because they're very complex. And we've focused on other areas that are very complex to either become an expert or to do the testing. Areas like forms. Form testing can be quite complex, and tables are very difficult to make accessible. You need a lot of accessibility knowledge. But the tool will inspect your application. It'll ask you questions about the application that are application-specific questions. It'll say, what is the intent of this particular piece of the application? What is this intended to do? Is this intended to be interactive or not interactive? And then it uses heuristics and artificial intelligence to find issues associated with that, capture all the information about those issues with screenshots, and give you targeted information that makes it very easy to fix. If you're a tester that's doing this testing as part of your testing, it gives you a very easy way to share that information with the rest of your team. So you can have URLs for individual issues, or for the shared report that you can share, put into Jira or put into GitHub or a similar type of system. And with this automation and the intelligent guided tests with Axe DevTools Pro, if you're including that in your pull request work, you can find and fix 84% of those issues before your pull request even gets merged. And that's a huge reduction in the risk within your organization, or it's a huge improvement in terms of the usability for people with disabilities, and therefore you're going to capture a larger market share where people with disabilities are using your application. So as we've gone through this process, what we've discovered in creating these tools for developers, and this was one of the main motivating points for when we created Axe Core, it was we wanted to create something that would be used by developers. And what we found is over previous generations of our testing libraries is that false positives were deadly. So we tried in the beginning to find as many issues as we could, but we had a lot of false positives in there. And what we found was that the tools just ended up not being used. They ended up being abandoned. Any reports that were generated from them were not looked at all. And we really weren't achieving our mission of digital equality. And so one of the things that we've really focused on a lot is making sure that all of our tools have this zero false positive approach to them. And that's one of the reasons that why when we adopted artificial intelligence and embedded that into our intelligent guided tests, we did it in this human-centered way. So we use, for example, computer vision models to actually look at the screen, to see the rendering of the screen, and to try to determine, using object detection, what sort of user interface objects are on the screen. And we created our own custom models because user interface screens are very dense with objects. There's a lot of objects that are hierarchical in nature, and this is very different from the object detection that you get for kind of real world problems that are not user interfaces. So we created a object detection model that's very good at this sort of hierarchical thing, also at identifying things that have very different shapes. So you have user interface components that are long and thin, some that are tall and thin. And so that's very different from most of your real world objects as well. So we use object detection, object character recognition, and other visual text and visual renderings to do a lot of the things that we do inside our intelligent guided tests. So let me walk through a couple of the problems that we solve with this. So our object detection model understands various aspect ratios and can find and identify a lot of different types of objects. So on this little image down here, you can see an image of a table. That table has a row that goes across, which is the header rows for the cells. And our object detection model is able to detect that table and detect that the various different cells, some of them are headers and some of them are data cells. And then what it does with that information is it presents the user with a question. It says, we've identified what we think is a header cell here. It's not marked up as a header cell. Do you agree with us that this is a header cell? And just by clicking a button, the user can then say, yep, I agree with you. And then it does all the rest of the accessibility analysis without requiring the user to answer any questions about accessibility whatsoever. So that's an example of a principle of applying that question about the intent of the user interface object together with an artificial intelligence model that's actually doing object detection, and then some heuristics that tie that together to look at the underlying markup to then arrive at a result and be able to tell the developer how to fix that. Another problem that you have often in user interfaces is association of things using spatial placement. And one example of that is form fields and form labels and error fields. And so one of the things our model is able to do is to do the OCR to detect all the text that's on the field, find the placement of those fields, and tie that together with the object detection to associate what could be labels or error messages with the input fields that they're associated with. And then we can use that information to ensure that is also presented in such a way that a screen reader can read that out for the user who can't see the information presented on the screen. Another way that we use the visual presentation is in complex color contrast analysis. So you can see here in the background the hello world text and a goodbye world text, and both of them are rainbow color text, but the one is on a darker background, and so half of the text is not visible. The Axe Core library, because it's a portable library that can work in in-browser context or whatever, it's not able to do the analysis there, but the Axe Pro tool, which is using the rendering of this, can actually look at that and resolve those sorts of color contrast issues. And then the final way we use it is by combining different states of elements, where we automatically put or ask you to put the elements into different states, and we check the renderings of those. We check color contrast and various different things in those various different renderings of those different states. And so that's how we combine our zero false positive capability with artificial intelligence and heuristic to arrive at things that make it very easy for any tester or developer to do a lot of this complex testing, which would otherwise be possible only with as a manual tester. And one of the great things about our application is that if you allow us to, we'll take your data and we'll use that data to make the tool itself better. And the way we do that is we send the data through our own models to look for more diverse data. That data then goes to human labelers. It gets automatically labeled using our model, but then it goes to human labelers to correct that either to add new models or correct those models itself, and then it makes its way back into the application. So every 2 weeks, we're actually looking at new models being shipped and made available. So let me switch now to show you very simply 2 different ways that these technologies can be used. The first thing I'm going to do is I'm going to switch to VS Code over here, and I'm going to, by uncommenting this code over here, I'm going to pretend to type in some code. And you'll notice that immediately as I typed in this code, there's some red squiggly lines appearing underneath this new code that I typed in. Here you can see it's saying this button element does not have an accessible name, neither does the image element. It's got a link over here that I can click on to get to information to tell me how to fix that. But for those of you who are astute, you'll notice that this button is a button with an uppercase B. So if I go to the top of my file over here, you can see that I'm importing this from a React component library. So how does our linter know that that button with an uppercase B doesn't in fact have an accessible name embedded into the implementation of the component itself? And the reason for that is that we give you the capability to define your own mappings, where you can map your components to the underlying attributes and underlying HTML elements, so that our linter then knows how to interpret those. And it can use that information to then make sure that your component library, which might be accessible, is used in such a way that that accessibility is maintained. So the great thing about that is it not only works inside the editor itself, but it also works inside your pull request. So if you have developers who don't have that plugin installed, they can also take advantage of that, and your pull request can take that into account. The last feature I really want to show you is within the interactive intelligent guided tests. I'm going to run Axe over here. It's going to do the automated tests. I'm going to save that, and then I'm going to run the keyboard interactive intelligent guided test for you to test for the keyboard accessibility. So I click start, and what it's going to do is it's going to automatically tab around this page for me, looking at all the interactive elements. And while it's doing this, it's doing a lot of the testing that you would normally have to do using a screen reader. So it's determining, are there focus outlines? Are those focus outlines good enough? Are these elements actually interactive with a screen reader? And simply by clicking next and next, I can then, sorry, back, no, there was nothing. I've got to answer the question correct. It then presents to me all the elements on the page that look suspect. So over here, we have these little buttons that pop up a dialog box, and it's saying, is this element interactive? Is it a scrollable region, or is it neither? And simply by scrolling through those, I can see, yep, those are all interactive elements, and it's going to capture all the information I need for me to know how to fix those issues. Here it's found some issues related to missing focus outlines, visual indicators, and here it's found some elements that are missing the appropriate role information for a screen reader to be able to interact with that. If I inspect this, you'll see this has been implemented with just a div with a tab index of 0. So obviously a normal keyboard can get there, but a screen reader, when it lands on that, is not going to have the events delivered to the JavaScript event handlers, and so a screen reader user is not going to be able to use that. So this is how simple it is to use these intelligent guided tests. And once I'm finished with them, I can click this button over here to get a shareable link that I can then put in, for example, a Jira ticket, which gives a full outline of all the testing that was done. Some of our more compliance-minded customers, like banks, will use this report to add it to their pull request for review as evidence that the testing was done. That's my presentation. I'd like to hand it over to see if there's any questions that anybody has.